Welcome back. Today's Fusion Mondays, week 17A. We're going to take this flange bolt and learn how to create a technical drawing. Stick around. It's going to be a fun one. Okay, let's get into it. So we're going to create a technical drawing of this flange plate, designed from drawing. Okay, we're going to go to template, and we're going to choose the 11 by 8.5, which is a landscape template on 8.5 by 11 sheet. We're going to click OK. And we're going to go ahead and place the first view. I think we can get away with a 2-to-1 because part of the thing today is we're going to talk about that. Now let's talk about setting up the title block and the notes, and then we'll get into the dimensions. So first thing, let's do the notes. This is going to be 1018 steel. Remember, the more you the tighter the specification on the material, the more money it's always going to cost. The coating is raw. It'll be welded onto a piece of pipe. And then we are going to actually add a note to the bottom of this, which is going to say stock 0.5 plate. Now, by doing that, we can get away from having to do a right side or top dimension. If it's just a flat plate, this is normally acceptable. Remember, the goal of a technical drawing is to fully convey what this project is to a manufacturer and how to make it. If I do a right side view, which I can show by just doing a project, and then we'll do the isometric while we're at it, and click OK. And we're going to turn the isometric into color, and we are going to turn off on this one hidden lines, which all we end up with is a rectangle. And the only dimension we put over here is a 0.5. It's the only thing useful. So I can avoid this, ease up the reading of the drawing by adding stock is 0.5 plate, which basically says, hey, it's just a flat piece of material. We don't have any profiles. So I'm going to go ahead and delete it. So now I'm back in the model. If I go to physical properties, I can then select metal, and I should be able to find 1018 steel. So we're in stainless steel. So 1018, there's a few different variants of it. I don't think they just have a straight version. So we'll use 1018 106HR, which is not what I just care that it's a 1018 steel. I don't actually care which one it is, but we need that to get the weight. And then we can go over here and go to properties, and here is our mass, which is 30.861 ounces. Okay, so let's go ahead and finish up the title block, and we're going to double click on it. There we go. IED is the class. The drawing number is 050 for my Fusion Mondays assignments. This is week 17, and this is the first one of week 17. We are in, this is being recorded in 2021, and it's the first version of it. And we could type in 30.816 OZ for ounces so that we get it fully, all the drawings done. Oops. I forgot to hit enter. 30.816 OZ, enter. There we go. Finish property. Now we have the drawing title block done. We have all our notes, including specifying the thickness. So now we need to dimension this. So I always start with our center marks. We need to do a center mark pattern because this is a circular pattern of holes. So we're going to hit center mark. We are going to click on each circle, which should give us the full pattern. And we can click OK. We need to do a center mark of the entire part. So now we have our center marks on, and we just have a handful of dimensions to do. So the first dimension is what is the outside diameter. It's 6 inches. What is the inside diameter? It's 4 inches. The center of all of the bolt pattern is on a 5-inch diameter. Now, next what we're going to do is I actually am going to move this 6 to like over here because I need to put an angle between this line and, where was it? That line. And we can do 45. Now, because we have a circular center mark and we're giving us the angle, the manufacturer understands that that angle applies to each one of those. Each one is 45 degrees apart from the other one. Now, we're going to use the whole thread command because these were created with the whole command over on the model side. So we're going to click on this and we can then just drag this out and it's going to give us all the relevant data for this bolt pattern. So the only thing here that we have to worry about is precision. So we want a little bit higher precision than the 0.1 that a single decimal point gives us. So the only way to really give us that higher precision is to override it by typing in the trailing numbers that we want. And by doing this, we have now specified a precision of plus or minus 0.02 or 20 thousandths versus a tolerance of, well, I actually didn't even give a tolerance because I didn't have even a decimal point at all. So this makes it much clearer. The manufacturer would have interpreted the 4 as the highest tolerance of plus or minus a tenth, which is a huge tolerance. So now we've tightened up the tolerances quite a bit. We can also go down here and add a 0 behind that 5 if we wanted to hold a tighter tolerance or plus or minus 20 thousandths. And also that would give us a uniform value across all of this drawing. So we're now done. We have a fully complete drawing. We're ready to hit print or send it out for manufacturing. Hope it's useful. Hope you learned something. Catch you in the next one. Have a great day.